Okay, we're going to get started. We're running a little late because the last session ran a little overtime. I've got a lot of content to cover today. So just to welcome you and make sure you're in the right place. I'm Ben Armstrong. I'm a program manager on the virtual machine team. And I'm here to talk about tips and tricks for developing and testing with virtual PC. Before I get going, just kind of see a raise of hands from the crowds here. How many people are using virtual machines of some kind today in development and testing? That's fantastic. That's exactly what I wanted to see. So hopefully, you're probably going to know bits and pieces of what I talk about today, but hopefully each of you will go away with something new and cool and a new idea of what to do with virtual PC and what you can do with it in development and test environments. So having seen the raise of hands, most of you are probably going to be well and truly familiar with why you should use virtual PC in a development and test environment. Obviously, it allows you to run multiple operating systems on one computer at the same time. And this is a great benefit for development and test environments. Beyond that, there's great things you can do with virtual machines and the virtual networking capabilities. You can also rapidly create, reconfigure, destroy, and recover virtual machines, which is also really handy in a development and test environment. And it's also very useful for testing beta and pre-beta software. I've had a number of questions over the course of this PDC about running Vista inside of virtual PC. I don't have anything specific about Vista inside of this presentation today. You can run it. It's kind of tricky to get up and running, and it's a little slow at the moment because we haven't got updated virtual machine editions for it. But if you want to find out more, please check out my blog, which I'll reference at the end, and we have details there on how to get Vista up and running. So now moving on to the tips and tricks. So one of the first things that I always get asked about, especially from people who are using virtual PC for development and tests, is what can I do to get more performance out of virtual machines? So the simple answer is the faster and more of everything you can get, the better. However, there's a fair amount of detail that needs to be hammered in on each of these points. So when we're talking about CPU resource, when we say more, what we mean is faster. So virtual PC will only utilize one physical CPU in the computer. So moving to a multiprocessor box won't give you that much of a boost inside of virtual PC. What's more important is having a single fast processor. Having said that, my personal home machine that I use for playing around with virtual PC is a multiprocessor box. And the reason why I have a multiprocessor box is because I run virtual PC and I run Outlook and Internet Explorer and my development environment. And by having two processors, I can ensure that virtual PC gets all of one processor to itself. So the next area to look at is memory. And this actually causes a lot of confusion for people because the challenge is trying to figure out just the right amount of memory to assign to your virtual machines. So I'm going to give you some quick rule of thumb guidance for what I use for sizing my virtual machines. So the first thing to keep in mind is when you assign memory to a virtual machine, we wire that memory down and the host operating system cannot get access to it. So virtual PC is one of the few applications where you can starve the host operating system of memory. If you assign all available memory to the host operating system, if it tries to do anything else, it's not going to have that memory available, and you're going to get paging on the host operating system, and the whole system performance, both the host and the virtual machines, is going to go down. So my first rule of thumb is when you're thinking about sizing your memory, just have your host operating system running the usual task load set that you have, running Outlook, running an internet browser, whatever. And then bring up Task Manager and have a look at how much physical memory it tells you you have available. On my laptop, which I'm going to be doing my demos on here, by the way, it's a 2 gig Centrino with 1 gig of memory. When I do this, Windows usually tells me it has just over 600 meg free. So I then take that and say, okay, I want to leave about 100 meg buffer. Just so, if I launch any other applications or if I'm doing something and Windows needs to have more memory to do that operation, which leaves me with about 500 meg to run my virtual machines with. So then, knowing how much memory we have to play with, we start looking at giving appropriate amounts of memory to the virtual machine. So the first thing to know is each virtual machine will have about a 25 meg memory overhead. So you can calculate, okay, if I assign 128 meg of memory, virtual PC is going to use about 153 meg. The next thing to be thinking about is, what is the workload that I'm running inside of these virtual machines? So today you're going to see me doing a bunch of demo virtual machines. And they're going to be a very light workload because they're only being used by one person. For instance, I have a web server demo where it's serving up a static web page and it's being hit by one client, me on my other virtual machine. So in that situation, I can assign 256 meg of RAM to that virtual machine, and it doesn't utilize all that RAM, and it runs quite fine. And given that workload, if I went ahead and assigned a gig of RAM to that virtual machine, it's not going to make any difference for performance of that virtual machine because it doesn't have the workload to use that memory. And all I'm doing is needlessly taking that memory away from the host computer and risking running out of memory there. So it's important to think about the workload and really think about how much memory is appropriate for each virtual machine. So next point is video. As most of you probably know, we do emulate a 2D video card. You don't get any of the cool 3D acceleration. However, when you have multiple virtual machines up and running, you have 3 virtual machines and they're all drawing desktops at 1024 by 768, we can really tax today's video cards. And I actually personally like to use multi-monitor systems and have found that getting higher-end video cards really helps with the responsiveness and just the feel of running virtual machines. Then there's storage. I'm going to drill into this more on the next page. But finally, and hopefully you all know this, always install the virtual machine editions. Please, 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 please always install the virtual machine editions. They make a really great performance improvement. And later on in this deck, I'm going to drill down and discuss what it is exactly that the virtual machine editions install and how they work. So, moving on to storage. Disk I/O is actually a significant bottleneck for performance on modern systems running virtual machines. It used to be when we first started working on virtualization products for PC that CPU was the main bottleneck. And these days CPUs are really fast and they're really up there, and we're starting to see that disk I/O is becoming a problem. So the first piece of advice is, where at all possible, use a separate storage device to store your virtual machines than what you're using to run your host operating system. It's important to note that taking a single hard drive and partitioning it and putting your operating system on one partition and your virtual machines on another really doesn't give you a performance boost because you're still the same physical device. But if you can get just a second hard drive in there and run your virtual machines off of that, you will see a notable performance improvement. And if you're using a laptop like I'm going to be using in today's demos, highly recommend that you get an external USB 2 or FireWire drive. I have a USB 2 drive here that I'm going to be using to run all of my virtual machines off. And the second point about storage is to watch out for fragmentation. I'm being given something. It says overflow room to 410. Hopefully you know what that means. The second thing to watch out for is fragmentation. The default virtual hard disk that Virtual PC uses is what we call a dynamically expanding virtual hard disk. And the way this works is we start with a very small file on your computer, and as data gets written into the hard disk, we write data out to that file and we expand it. And you can get a problem where if you're running multiple virtual machines at the same time with dynamically expanding hard disks and they're expanding their hard disks, you can get very bad fragmentation on the host operating system. So keep an eye out for that. Try and make it part of your routine to check the fragmentation level of your host operating system. Just a heads up, if you're using the built-in fragmentation tool in Windows, it will not defragment really large files like the virtual hard disk files. So your choices are to either move the files away and then defragment your hard disk and then copy the files back, or to get a third-party defragmentation program like, for instance, I use Disk Keeper. So those are two big pointers for Disk I/O. So now to just talk about some tricks and try and show some samples of how it is that you can tweak performance and tune it with Virtual PC. I'm going to switch across to my laptop And here you can see a lovely little application called Foxbear. This is a video test application that's available as part of the DirectX development suite. And I like it because it uses all the CPU in my computer. To draw this little animation, it's just in a tight loop, and you can see it's telling you the frames per second up the top. Only when it was first written, they didn't think that a computer would ever get more than 100 frames per second. So I'm currently over 100 frames per second, and that number's a little messed up. So we're currently running with the default performance settings for Virtual PC. And if I just bring it up in Task Manager here we are. You can see there's my Virtual PC running, and it's using 99% of my host CPU. And it will always do that. This is the default setting, and it's a great setting for if you're playing around in virtual PCs because everything's going to run as fast as it possibly can. The problem with this setting is if you're trying to run something in the background in virtual PC and you're wanting to browse the web, check your email, work in another application, if the virtual machine decides to use all the CPU, it can really slow down the application you're trying to use. So Virtual PC does have some performance options. So here we have the option to say run Virtual PC at maximum speed, which is the default setting, or say give processes on the host operating system priority. Now, if I select that option, I bring my virtual machine back up. When it's in the foreground, it runs fine. It's running like it always does. However, as soon as I put it in the background, Virtual PC throttles back, and we only use about 30 to 50% of the host processor. So the flip side of this is, okay, this is great if you're using other applications. However, it's not so good if you're using a light load application, like let's say I'm doing an OS installation and it's going to take an hour and a half, and while the OS is installing, I want to browse the web. I want my browser to be responsive. However, I don't want Virtual PC to be throttling back like this. So this kind of leads to a third option, which is a little bit of a trick, but it's one that I use quite regularly when I'm on a uniprocessor machine, is you can say run Virtual PC at maximum speed, so that we're back to having good performance. And then come into Task Manager and just set the priority to below normal. And by doing that, if you're doing a light load process in the foreground, like running Internet Explorer, Virtual PC is still going to get 95% of the processor, and your web browser is going to be responsive. So let's just put that virtual machine away. So moving back and touching some more on storage. I mentioned before that Virtual PC uses dynamically expanding disks by default. And I've mentioned the downsides of that, and the biggest downside is the risk of fragmentation. Having said that, I still use dynamically expanding disks for almost all of my virtual machines because I just find them so convenient. But there are other types of virtual hard disks, and it's important to understand when you should use what type and what the upsides and downsides are. So the next most commonly used type is the fixed virtual hard disk. And this is, you create a 16 gig virtual hard disk. Virtual PC will take up 16 gig on your physical hard disk. The obvious downside to this is you just lost 16 gig off your physical hard disk. The upside is you never have to worry about fragmentation issues. And there is a performance improvement with using fixed disks over dynamic disks. Whether that's worth losing all that space that you may not be using or not is a call for you to make. Like I said, I still use dynamic disks, even though I know that fixed disks would lower my chances of fragmentation. The next option is differencing disks. And this is where we have allow you to create a base virtual hard disk, create child disks off that store the differences. And it's a really cool way to create clones and use templates and rapidly provision virtual machines. One important thing to know with differencing disks, though, is we store all the differences that are written to the hard disk. And over an extended period of time of using an operating system, the differencing disk can actually grow to be just as large, if not larger, than the base hard disk that it's based on because you've made enough changes. So a general rule of thumb is if you want to use a master disk in a template scenario, and you're planning to only use the virtual machines for a couple of days, maybe a week or so, differencing disks are great. However, if you see yourself using these virtual machines over a period of months or long term, it's probably wiser from a space usage point of view to just make a copy of the base disk rather than using differencing disks. And finally, there's undo disks. Hopefully, you're all well aware of undo disks. They're a great tool. Allow you to just play around with the virtual machine and throw away the changes. I'll be doing some demos that use that functionality later. And one final point just to make is Microsoft has recently announced that we are licensing the specification to our virtual hard disk format. And if anyone in this room is interested, they should feel free to email vhdlic@microsoft.com, and you can get hooked up with the details on how to license that format and integrate those capabilities into your products. So that moves us on to networking. The networking capabilities of virtual PC are really cool, and they're one of the things that attract a lot of people to the product. So first I'd like to chat about the three options in virtual PC and just highlight some of the differences between them. We have, by default, we have local only, shared networking, and external networking, which is whatever physical network card you have in your computer. Local only is a private virtual network that you can only connect virtual machines to, and they can interact with each other. Now, the great thing about that is, even if you don't have an active network connection on your box, you can use the local only network and network between virtual machines. Shared networking is where we create a little mini virtual NAT router, and we allow you to connect your virtual machines to that. The upsides of this are, your virtual machines can connect to the internet without you having to worry about anyone trying to connect back to your virtual machines. This is incredibly handy if you're like testing old operating systems and you don't want to worry about making sure they're all patched and protected. Just stick them behind this. The downsides to shared networking are, when you're using shared networking, virtual machines can't communicate over the network with the host computer or with other virtual machines. So it's purely a virtual machine and internet scenario. Finally, there's external networking. And when you select external networking, your virtual machines are out there on the wire, and they appear to like separate physical machines on the network. They have their own MAC addresses, yada, yada, yada. Very powerful networking option. So one thing that I noted is we only have one local-only, virtual machine-only network by default. And one thing that some people know, not everyone knows, is that you can actually use something called the Microsoft Loopback Adapter to build up a lot more complex networking scenarios. So the Loopback Adapter is included with all versions of Windows, and you can install it on any Windows machine by going to the Add Remove hardware panel, and going down the advanced path and saying, I want to add a piece of hardware, selecting a network adapter, and in there will be the Microsoft Loopback Adapter. So coming over here, we'll see that the Microsoft Loopback Adapter to the host computer appears to be just another physical network card. So I actually have two Loopback adapters installed on this demo machine here. I've got the virtual public network, which if I bring it up, you'll see, I've got the host computer is a member of this network, and I've got configured for 192.168.10.10. And then I've got my virtual private network, and this is a network for just virtual machines. And you can see I've unchecked all the protocols from the host on it, so it can't use this network to communicate, but I've still got the virtual machine network services driver there, so that the virtual machines can connect to this network and use it. So using those two networks brings us to the next demo. And this is a really cool example of what virtual PC can do with networking. So what I actually have here is I have three virtual machines running at the moment. I have Windows Server 2003 box running IIS. I've just got some static web pages on here. And as you can see, I've got it configured on 192.168.20.10. Then, on the other end, I have an XP client box just running stock XP, actually connected to a different virtual network with an IP address and a different subnet, 192.168.10.20. And in between them, I actually have a third virtual machine running Windows Server 2003 with ISA server configured on it, and it's bridging the two networks. And I actually was interested in this because I like playing around with websites and doing ASP.NET development, and always interested to see how do different firewalls interact with this, and are there any problems when I'm running ISA server. And so this way you can see, if I pull this down, I've got the firewall client installed in my virtual machine, but it's not enabled. So if I open up Internet Explorer, it's going to come up, try and go to the web page and fail. It's on a different network. I can either enable the client, or I could sit and enter the proxy values. I'm enabling the client because it's a quicker demo. But now you can see I'm able to get to the web page that's being served off of the web server virtual machine. So that's just a quick example of the sort of power that's in virtual PC's networking capabilities. Just a second while I save state those virtual machines. So, another cool functionality of virtual machines, and I can assure you this is used incredibly widely at Microsoft, and that is the ability to use virtual machines to do remote debugging and to do development. So I have a couple of demos here. First of application level debugging, and second of kernel level debugging. So I'm just going to start those virtual machines. Now, in this demo, I'm going to be doing all of the development work, as it were, inside of an XP virtual machine. What I'm demonstrating could be done just as easily with my development environment on the physical machine. I'm just doing it inside of a virtual machine because I'm paranoid about breaking my demos. And running it inside of a virtual machine gives me that little bit of coverage. So the first thing I want to show is a cool combined functionality of Virtual PC and Visual Studio 2005. So here I have just a hokey little VB.NET app that I'm using for a demo. I have Visual Studio 2005 Beta 2 installed, and I can run it in debug. Up it comes. I've got a nice little button that all it does is hits a breakpoint. And I can go, oh, look, isn't that nice? Now, what's really cool about this demo is that I actually have this set up so that I have a Windows 2000 virtual machine here. Now, you might be in a situation where you're developing on one platform, but you have to ensure that your code works and runs on other platforms. So I have another profile here, Remote Debug, and I can just kick off that, and in just a second, up it comes on my Windows 2000 virtual machine. I can interact with the application, confirm that it works fine. If I hit a breakpoint or whatever, it breaks over here in my debugger. I can debug it just like it was running locally. That's really cool, and it's actually surprisingly easy. So all I had to do to set up this demonstration was, firstly, I made a file share on my development box, and I've mapped that share to the G drive on both computers. And that's what I'm using for the development. Secondly, I've installed the Visual Studio remote debugging tools on Windows 2000. Now, these come with Visual Studio, and they work on XP 2000, NT, Windows Me, Windows 98. Once I've installed those, all I had to do was create another profile for my project, and under the Debug tab, go in here and check Use Remote Machine and enter the name of the virtual machine. And using this capability, I'm now able to quickly develop and test on multiple platforms at the same time. Anytime I make a change, I can quickly test it out on the other platform. So that's an example of using Virtual PC to do user-level remote bugging. Another remote debugging feature of Virtual PC that's really handy is the ability to do kernel-level debugging. So normally in order to do driver-level, kernel-level debugging, you'd need to have two computers, a null modem cable, or a FireWire connection through them, et cetera, et cetera. So Virtual PC supports using named pipes as a connection between virtual machines. So here I have my target machine that I'm planning to debug. As you can see, it's connected to, has its COM1 connected to a name pipe. I already have this machine connected to that name pipe. I can start up the debugger over here. It's going to come up. This virtual machine's all pre-configured, ready to go. And you'll see in just a second that the development machine is going to pick up that the virtual machine's there, and it's going to connect the debugger. Now, one of the cool things about this, again, as I was stating, is you don't have to do this inside of two virtual machines. I'm just doing it for personal ease with this demo. You can actually have the debugging tools installed on your physical machine, connect directly to the virtual machine over the name pipe, and do kernel debugging of the virtual machine. So here we can see the virtual machine started booting. I'm going to come over to here. I'm going to just break into the debugger. And I can do anything that I would normally do with a debugger. I'll have a quick look at the drivers that are loaded. Everything's there, all the functionality that you would normally expect, and then I can let the virtual machine get up and running again and continue through the boot process. So that's just a sample of how powerful virtual machines are when it comes to debugging different platforms at different levels. So, next thing to talk about is Interesting things about safe states. Now, as I've been mentioning, I've been using safe states for all of these demos. Hopefully you guys use safe states a lot. It's a great way to just quickly suspend a virtual machine and bring it back. So a couple of things that aren't widely known about safe states. Firstly, they're more portable than most people assume. So the way we work with safe states is when we create a safe state, we record the features that are supported by the processor that we're running on. For instance, SSE2, SSE3, 3D Now, etc. And when we go to restore the safe state, all we're really looking for is a processor that supports those features. So you can have two different models of processors, even from different manufacturers. As long as they support the same feature set, you can move a safe state between them. An example is I have my Centrino laptop, and I have a P4 workstation at work. Now, different processor families. However, both processors support exactly the same set of features, and I'm able to save state virtual machines on one, move them to the other, and restore them with no problem. You should also be aware, if you're thinking about doing this, though, that there are a number of save state movement paths that are only one way. For instance, if I had a P3 and a P4 computer, I can create a save state on the P3 and move it to the P4, but not the other way around. And the reason for that is the P4 is a superset of the P3 and has all the processor features of the P3, but the P3 doesn't have all the processor features of the P4. So the second point I want to make here is that virtual machine save states are reusable if you're careful. So I'm just going to bring out my next demo and show you what I mean by this and show you how you can set up a virtual machine such that you have a safe state that you can go back to over and over again. So for this demo, I'm going to use my favorite virtual machine, Microsoft Bob. So here we are. We're at the front door of Microsoft Bob. The little dog's there waiting for us to log in. And I might decide that, okay, this is the point that I want to always be able to come back to, because goodness knows it takes so long to boot Microsoft Bob, and I want to just be able to show it off whenever I want. So I've just said save state and keep undo disks. I have a shortcut here to the folder that's in. So you can see here we have a bunch of files. One is the little batch file that I'll be demonstrating in a second. One is the virtual hard disk file for that virtual machine. One's the virtual machine configuration file. Then we have the save state file and the undo disk. So what I can actually do is I can take the configuration file, save state file, and undo disk and make a backup copy of them. Now, if I come back to my Bob virtual machine, I can, let's say, log into Bob. Yeah, I guess that's fine. And I can go into the wonders that is Bob, and I might get bored and I might decide to trash my lounge room, which actually is possible in Bob, it turns out. So I'm just going to move my furniture all over the place. I'll put the fire over here, I'll move the calendar, I'll put the safe, in the window. And, now I might go, oh, I didn't want to do that. And I'm never going to be able to figure out how to get all my furniture back in the right place. So I'm going to say, okay, let's turn off and delete these changes. But I want to be back to where we were with that save state. So all I really need to do is go and grab the save state, undo file, and configuration, and copy them back to where they were. Yep. And 2 seconds later, we're back where the save state was. Now, you can do this over and over again, and in fact, the only thing that'll stop this from working is if you were to commit your undo changes to the base virtual machine, base virtual hard drive, because that would invalidate the copy of the undo disk that you made. Now, if you want to do this a lot, and you're worried that, hey, I might accidentally commit the changes, what you can actually do is once you've created this save state that you want to use over and over again, come into the virtual hard disk and just check read-only. Because if you do that, now if I have a mental lapse and I forget that this is my Bob machine that I want to keep just the way it is, and I said, okay, let's commit changes, Virtual PC is going to come up and it's going to say, I couldn't commit changes because you don't have write access, and it's just going to keep the undo disk around. And finally, if you're really lazy like me, it's incredibly trivial to just make a little batch file that'll do the restore operation for you. So I can just go restore, and now my virtual machine is back to the way it was. It's a really cool little trick there. So next trick I'd like to discuss, what I call tweaking the VMC file. So as I mentioned before, the VMC is the virtual machine configuration file. This is actually an XML encoded file, and it's quite human readable. One thing to be aware of, though, is that it is UTF-8 encoded. And we've had experience where some XML editors out there will save it in different encodings. They don't support UTF-8. And if that happens, then Virtual PC won't be able to open the file. So be warned about that. I use both Notepad and the Visual Studio XML editor, and it works fine with both of them. So I'm just going to, I've got a shortcut to a VMC file here. I'm going to open it up with Visual Studio and just give you a quick look at it. Now, unfortunately, we haven't released any public documentation on the format of this document. I hope that we do one day. But for the meantime, as I mentioned, it is human readable, and it's actually quite easy to see what's appropriate values to put in here and what's not. The worst thing that can happen if you put an inappropriate value in here is Virtual PC will refuse to load the configuration, and you can go and undo the change that you just made. So there are a lot of interesting things in here. For instance, memory size, hard disk configuration, all the configuration options. For instance, here's the information of like the BIOS serial number and motherboard serial number that we report inside the virtual machine. And the great thing is this is a fully standard compliant XML file. So if you want to write a program that will automatically parse these and make changes, that works fine. So just to demonstrate this, I'm going to randomly change my memory, say to 182 meg. I'll save that file. And now if I come over here to my virtual machine, I can power it up, and we'll see 182 meg. So it's really that simple, and highly recommend that if you're looking at doing any automation with Virtual PC, just have a look at the format and see if there are settings that you need to change, how to change them. So now to talk about something which I'm not going to do a demo of virtual machines, but this is actually something interesting to know. And that is the fact that Virtual PC and Virtual Server have a number of shared components. Now today we have Virtual PC and Virtual Server, they're two products. And we support running them on the same system side by side. When you do this, there are three key shared components. VMM.sys, which is our virtual machine monitor driver that's responsible for the low-level operations of the virtual machine. The virtual machine network services driver, and the virtual machine additions. One interesting thing to know is on the virtual machine team, we do support both applications installed at the same time. And we do testing to ensure that if you install the latest version of Virtual Server, Virtual PC will still work. So one trick you can actually do, because as happens in life, quite regularly we'll release an update for Virtual Server, and it'll include something that's not in Virtual PC yet. Or we'll release an update for Virtual PC, and it'll have something that's not in Virtual Server. If that update is in these shared components, you can actually kind of get that benefit on the side. For instance, Virtual Server R2 that's about to come out has a lot of performance benefits in it. A lot of those changes were in the virtual machine monitor. So if you install Virtual Server R2, you'll actually get a performance boost inside of Virtual PC as well. So that's just an interesting point to know. So, anatomy of the virtual machine additions. As you've heard me say, and as I'll quite happily admit to, we say over and over again to people, install the virtual machine additions. Well, I regularly get asked, hey, what are the virtual machine additions? What are they doing to my virtual machine? And this happens both out of just general curiosity. And as much as I hate to admit it, occasionally we do get someone hitting a compatibility issue that only happens when the virtual machine additions are there. So now I'll do a quick step through and show you what the three major sections of the virtual machine additions are. So the first section is drivers. We install a couple of optimized drivers for our virtual machine to get better performance inside our virtual machine. On Virtual PC, the two main ones are the Virtual Machine S3 Trio driver and the Virtual Machine Mouse driver. Together, these two drivers give you better video performance, and they give you the nice integrated mouse where you don't have to uncapture your mouse each time. On Virtual Server, we also install an optimized SCSI driver for our emulated SCSI controller. So the second part of the virtual machine additions are these two services that you can see listed here. Now these services are responsible for doing all the neat little cool integration things that we do. like drag and drop, folder sharing, shared clipboard, time synchronization, etc., etc. Now, this one, we do, it's not uncommon to hear situations where people are like, hey, look, I'm doing a test, and I really don't want time synchronization running while I'm doing this test. Or, hey, I'm doing a test, and something's happening with the clipboard, and I want to make sure it's not your guys' components. So just to do a quick demo, one of the features these services enables is the ability to dynamically resize the virtual machine desktop. So with the services running, I can resize this window, and the virtual machine resizes, and we can go back, and everything's happy. Now, if I come in here, and I disable this service, and I come here, and I can't resize the window anymore. The service isn't running. The integration features are now effectively disabled. I can start that service again, and away we go. Now, unfortunately, today, this is pretty much an all or nothing. Once you stop the service, all the integration features stop. Drag and drop, share clipboard, folder sharing, time sync, everything. We've heard very definite feedback from people that we need to provide a more granular way of doing that in the future, and we do intend to. But this is what we have today. And the final thing is one key driver, the virtual machine services driver, which we can see there in the System32 drivers folder. Now, what this driver is responsible for is this is what really gives the speed improvement when you install the virtual machine additions. We load this as a driver inside of the virtual machine, and it's responsible for applying a number of optimizations to the guest operating system so that it can run as fast as possible inside of a virtual machine. By the way, this is also the reason why it's not uncommon that when we release a new operating system, we also have to release updated virtual machine additions in order to get good performance. Because when we release a major update to an operating system, we've quite often made changes to kernel structures and different things in the operating system such that we can no longer apply the optimizations that we want to. This driver is designed such that if we can't apply the drivers, it'll just quietly not load, and it won't cause any problems to your system. However, the system will run slower. So that's pretty much it for the virtual machine additions. So next thing I want to talk about quickly is time synchronization. As I mentioned before, we do time synchronization in the virtual machine additions. And I get a lot of questions from people who are just curious about what's up with time inside of virtual machines. Why do you guys seem to have so much trouble with this, and why are there all these little add-ons and workarounds and so on? So the first thing to know is time inside of a virtual machine is not reliable. This comes from two aspects. Firstly, most operating systems, when they're running on a physical computer, quite rightly assume that they own all the hardware, and that if they think a second has passed, a second has passed. Well, when they're running inside of a virtual machine, they're sharing the hardware with other processes, and at any stage, they could be preempted by another process on the host operating system. And when they come back to execution, they may think a second has passed, but really a second and a half has passed. And they have no way today of knowing that that change has happened. The second thing is, inside of a virtual machine, standard CPU operations may not always take the same length that you expect them to. Now, you don't notice this when you're running just a high-level application because it all comes out in the wash, and the differences are, in the magnitude of, milliseconds, if not smaller. However, there are a number of low-level programs that, make calls, do things inside of the machine, going, well, I know if I do this call, it will take exactly, half a millisecond, and I'll use that as my timing routine. And then they run inside of a virtual machine, and it turns out that inside of a virtual machine, that call takes 3/4 of a millisecond, and now their timing is off. So there are three ways that you can deal with time synchronization inside the virtual machine. The first one is the real-time clock in the BIOS. All BIOSes have real-time clocks. Unfortunately, most programs don't use them, but inside of the virtual machine, we do always guarantee that if you check the value of the real-time clock, it is accurate. The second one is by doing network time synchronization. And this is quite common, and in fact, if you have a Windows virtual machine and you join it to a domain environment, you'll automatically start doing network time synchronization to that domain environment. And the final option, which I've mentioned, is via the virtual machine additions. When you have the virtual machine additions installed and the integration service running, we will automatically synchronize the time. I think we do it every 15 seconds, if I remember properly. So that's pretty much it for the tips and tricks presentation today. I hope it's been interesting for you guys. I have a couple of more resources that you might be interested in looking at. Firstly, there's the official Virtual PC website. There are a couple of interesting white papers up there. Definitely have a read of them. There's the Virtual PC news groups. We have an absolutely wonderful community, a great group of MVPs, and if you go and post there, I'm sure that someone will happily help you out and give you information. And finally, hopefully, many of you already know about my blog. I run the Virtual PC Guy blog, and in fact, after this convention, I'm going to be putting a lot of the content from this deck up on my blog, but feel free to check that out also. So thank you all for your time.